So, this will be a review on your projectile motion. So, take note that yung projectile motion nyo is the motion of an object thrown or projected into the air, subjected to only the acceleration of gravity. So, pag binato mo yung bola, let's say this is the particle, if you throw that into the air, meron tayong path na mabubuo, and this path of motion is called the trajectory of your projectile. And then, if the trajectory will go down to the same datum of your initial position, so if we have initial position is equal to your final position at y, therefore this is a symmetrical projection of your projectile motion. And then I may say that this will be my range or my x maximum value of my x position. So take note, since we are dealing with two-dimensional motion, we will break this down into its x and y components. Okay, so if you are talking about a vector quantity, you all know that your vector quantity has two components, your x component and your y component. So take note that your displacement is a vector quantity, therefore it has two components, your x and y components. So how will we analyze the motion of a projectile? Simple. Parang nag-a-analyze ka lang ng motion of a vertical and a horizontal motion separately. Okay? So, if you would break down every component of a projectile motion, you can see that we have our Vy. If we have our velocity, so i-enlarge ko lang to. Let's say I have my velocity. This is our velocity. Let's say V. And then, the component of Vo, we have our Vx and our Vy. Of course, your angle. Take note that the angle is the angle where the particle will be thrown or launched. Okay? So, how will we solve for your Vx? Sokotowa. Or Sokotowa, Soka. Opposite over adjacent. Adjacent over hypotenuse. So, let's say this will be our projection of our Vy and this will be the projection of our Vx. So, let's say this will be your Vy. So, ipo-project ko lang to dito ha. So, therefore, I will have ka cosine theta is equal to adjacent or your Vx over your hypotenuse Vo. So therefore your Vx is just equal to Vo cosine theta cos theta. And then our Vy, so Vy is just so tama, opposite over hypotenuse. So sine theta is equal to opposite your Vy over your hypotenuse Vo. So therefore our Vy is equal to Vo sine theta. This is the breakdown of your velocity, Vo. Okay? So, next is your acceleration. So, as I have mentioned, that your projectile motion is the motion of the object thrown or projected into the air subject to only the acceleration of gravity. So, meron ba tayong AX and AY? Particularly, your acceleration is a vector quantity. So, therefore, meron yan. So, if you have your acceleration, let's say this is your acceleration, and then, let's say, ito to, may AO ka. So, take note that your acceleration due to gravity is going down. So, pababa yan. And then, meron kang to. Right? Ito yung projection natin. So, therefore, since we have our, let's say, AX and AY. Okay? So, may iba tong araw mo, di ba? Pababa dapat to. Kasi pababa yung projection natin. So, pababa ganyan ng AY natin. But take note, guys, that based on the definition of projectile motion, is the motion or the motion of the object thrown or projected into the air subjected to the only acceleration of gravity. So from that preposition, I may say that my AX is 0. Okay? AX is 0 and my AY is equal to negative AG. So if you would get the value of your AO, so ito yung AO natin, our AO is equal to square root of AG squared plus AX squared, which is particularly equal to negative multiplied by negative is positive, so AG, so square root of AG plus 0, so square dyan AO, therefore our AO is equal to the acceleration of the gravity. Okay? Acceleration of gravity. And then, so as I have said earlier, your projectile motion has two position, your X and Y position. So therefore, my S at X motion, S is equal to X, and S at Y motion, or your vertical motion, your S is equal to Y. And then particularly, if you get the value of your position, may X and Y kayo, so therefore, pag may X and Y ka, you can get the value of your position. Right? That would be your R position. Okay? So, there are important formulas that can be used if you are using or solving a symmetrical projectile. Okay? But before that, I will present to you the formulas that could be used in your projectile motion. So particularly pag ako, dalawa lang naman yan. Your projectile motion at X component. So at X component, so we have our S is equal to VIT plus 1 half AT squared. So since I have at X component, my S will be equal to X. So therefore, I have X is equal to VIT plus 1 half AT squared. Ang secret nito is that if you are solving for your X component, all or your horizontal component, all of the vectors should be at X component. All vectors should be at X component. So what are our X component of your vectors? So madami yan, di ba? So based on our prenomination so a while ago, my X component for my velocity is your Vx, right? So I have my X is equal to Vxt plus 1 half. So all vectors, A is a vector. So therefore Ax, T is not a vector, right? So T squared. Take note that T is not a vector. So therefore, the time at X at your X position is equal to your time at your Y position, which is particularly your T. Okay? So, yan. But what is our Vx? Take note that our Vx is equal to VO cosine theta. So, VO cosine theta multiplied by T, which is equal to our X. which is particularly equal to plus. Take note that at your horizontal motion, we have our velocity. Your Vf is equal to your Vi. When you're talking about your Vx is equal to Vi, therefore we have our constant velocity and we have our zero acceleration. So Ax is 0, so 0 to, therefore our x is equal to Vo cosine theta plus t. So that value of x is any value of x within this range. So x1, x2, x3, x4, x5 hanggang x6 hanggang x range tayo. So up to x range. That is the value of our x. Okay? Next is how will we solve for our value of your y. So ito lang yung ilalagay kong x component. Okay? So at my y component, because all the formulas in your vertical and horizontal motion are applicable in this, the only key is for you to know how to translate them into their x and y component. So at my y component, so ano mo yung mga y component natin? Particularly, I will have my s is equal to my VIT plus 1 half 80 squared. Okay? Particularly, at my y component, my s is equal to my y. Okay? Ito yan. So, y1, y2, y3, y4, y5. And then, para makuha mo yung position niya, meron kang value ng y1, x1. Di ba? y5, x5, y1, x1. Right? So, at my y component, so s is equal to VIT plus 1 half 80 squared. So, I have my y is equal to, my y is just equal to VY t plus 1 half AY t squared. Okay? So, take note that our AY, so ito yun, is the acceleration of gravity. So, therefore, it is negative because it is against the motion. And our By is the y component of your velocity, which is particularly equal to our Vo sine theta. So, substituting these values, so we'll have Vo sine theta multiplied by our t plus our 1 half multiplied by our Ay, which is particularly your acceleration of gravity, which is equal to 9.81 meters per second squared, or let's say negative g na lang. Okay? Negative g for acceleration of gravity multiplied by t squared is equal to your y. Okay? This is another formula for any value of your y. So take note that these formulas are applicable when you are solving for any value of x and any value of y. Okay? Uh, the best thing in here is that we can particularly solve for your value of your t max and your t height. T height at the t time at t height. So, what is your t height here? Yung t height natin dito is particularly when your velocity at y is equal to 0. T max at Vy is equal to 0, we will achieve T max. Y max, I should have said. So Y max, ito yung Y max natin, or your maximum vertical position, or particularly your maximum height, max height. But how will we solve it using your calculus? Okay, calculus tayo, no? So, dali lang. By setting dy over dt is equal to 0, right? The derivative of your y, which is particularly your dy over dt, is your vf or your v. So, particularly, pag ginahanap mo kung ano yung vf mo, so that is your final velocity or the maximum velocity at a given time, which is equal to 0. So, dy over dt, setting your VO sine theta, g, are as constants. So, letting your VO sine theta as constant, so therefore we have dy over dt is equal to the derivative of VO sine theta multiplied by t with respect to t. So, pag nagde-derivative kayo, then you are setting this value with respect to the other. So, itong VO sine theta natin will be a constant. So, plus 1 half multiplied by negative g all over t squared. Okay? So, we are differentiating this equation with respect to dt or your dy. So, your dy, therefore, we have y prime or your dy is equal to VO sine theta. Take note that your VO sine theta is a constant. It has nothing to do with the value of y changing with respect to time. So, therefore, the derivative of t is equal to 1, right? dt over dt. And the derivative of your t squared is equal to 2t. So, take note that your g is considered as a constant in this equation. So, para natin siyang i-consider na constant dyan. Okay? So, from the derivative of t squared, which is equal to 2t. Ito yan. Okay? So, we'll have dy over dt or your y prime or your vf, which is equal to 0, is equal to our VO sine theta plus 1 half multiplied by 2 is just 1, right? So, negative multiplied by negative gt. Take note that g is the acceleration of your gravity, constant yan. So, therefore, our t or your time at max height, t max height, is just equal to, so, VO sine theta all over g. So, take note that this t is the value of your time at max height. So, at max height, we have VO sine theta over g. So, how will we solve for your max height? By substituting for the value of your t max. So, your max height, your y max or your max height is just equal to your, ang gamitin natin equation na, VO sine theta multiplied by t plus 1 half gt squared. But naging less na kasi itong negative ito minultiply na natin sa positive. So, our t is this. Okay? So, solving for our max of our height at max time, our max height. So, solving for max height. So, we have our time at maximum height. So, ito yun, VO sine theta over G. So, we'll have a value equal to, so, substitute natin dito, So, we'll have a value equal to VO sine theta multiplied by our T max height is equal to VO sine theta all over G. Tama ba? Ito yun. Okay? Which is this equation. Less our 1 half multiplied by our G multiplied by our T squared, which is VO sine theta all over G squared. So canceling out this g, so we'll have a value equal to VO squared. So multiply ko na dito VO squared sine squared theta all over g less our 1 half multiplied by our VO squared sine squared theta all over g. So we'll have a value of our max height. So your y max is just equal to VO squared sine squared all over 1 less 1 half is equal to 1 half. Okay? So paano nangyari yan? Gagawin mo lang. Factor out mo yan. VO sine theta squared squared divided by g. So magkakaroon ka ng equation ng 1 less 1 half. Okay? And then, by manipulating that equation, we'll have a value of your y max or your maximum height equals VO squared sine squared g. So this is another important formula. So take note that this is any formula when you are solving for the value of your y max plus the value of your datum pag hindi siya 0. Okay? That is the value of your y max. So, meron na rin tayong time at maximum height. So, itong time na to is pag meron ka sa maximum height na sinasabi natin. Ito yung time mo pag nandito ka sa pinakataas. Okay? Ito, pag nandito ka sa pinakataas dito. So, yun yung T-max height mo. So, what is your total time pag similar projection siya, and then you would go down at the same level of your y initial. So, tinutukoy ko is that ito. Okay? Pag nanggaling ka dito, and then babalik ka rito, which is a symmetrical projectile motion, so what will be your total time? So, madali lang, di ba? So, T1 plus T2. But what is your T1? Your T1 is particularly yung T-max height mo. Okay? And then since this is a sabihin natin symmetrical motion, so therefore, our total time of flight, therefore, T flight is equal to, our T flight is equal to T1 plus T2. But particularly, since this is symmetrical, like our vertical motion, so T1 is equal to T2. So, since T1 is equal to T2, therefore, I may say that my T flight is equal to T flight is equal to T1 plus T2. Since T1 is equal to T2 at symmetrical projectile, pag hindi kasi symmetrical yan, iba, at symmetrical, so therefore, I may say that we have T1 plus T2, so 2T1, so T flight is equal to 2T1. But if I am considering my maximum height, so therefore, my T flight is just equal to 2 multiplied by T at my max equal to 2 multiplied by VO sine theta all over our G. Solution. Formula. T flight is equal to 2 multiplied by sine theta all over G. So next is our maximum range. So how will we solve for our X? Take note that our R is our X max. Diba? X max natin yung R natin. But particularly, what is your R? So since, so gamitin natin to, diba? Kasi X lang din yan. Note that my X max is equal to my R. which is particularly equal to my VO cosine theta t. But what is my t? Take note that my t is equal to my letting t equal to total time of flight, which is particularly equal to 2t1 or equal to 2t at max height. So therefore, substitute mo na lang dyan yung value ng r mo or yung t mo. So therefore, we have VO cosine theta multiplied by our t, which is equal to 2 yung t o time of flight natin, 2 VO sine theta. So 2 VO sine theta all over our G. So particularly, masosolve mo yung value ng x max natin or yung range mo, which is equal to VO squared cosine theta sine theta multiplied by our 2 all over G. So take note that our cosine theta sine theta, so cosine theta sine theta multiplied by 2 is a double angle formula for your sine 2 theta. Right? So since this is equal, ito, so I may say that my R or my X max is equal to R, which is equal to VO squared sine 2 theta all over my G. So yan yung formula natin for your maximum X or maximum horizontal component or your R or your range. So meron pa tayong formula na isa, which is particularly yung tinatawag nilang formula of trajectory. So formula of trajectory, so if you are talking about your formula of trajectory, you will see the x and y component into that formula. So formula of trajectory. So paano natin ngayon susolve to? So we all know that considering our y motion, so considering our y motion, meron tayong y is equal to ito VO sin theta multiplied by t plus minus kasi consider natin yung g at your acceleration. So negative g multiplied by our 1/2 multiplied by our t squared. So take note that as I have said a while ago, so your tx is equal to your ty, which is equal to your t. So lalagay natin yung x component dyan. Pwede natin gamitin to, tama? So by further manipulation of this equation, I may say that this equation can be equal to, so t is equal to, bababa natin to dito, cross multiplication, so may 1 dyan. So we have x divided by VO cosine theta, right? So substituting this value of your t here at our trajectory formula, so we'll have a value equal to y equals VO multiplied by our ito sin theta. So yung t natin, which is vertically equal to x all over VO cosine theta less our g multiplied by 1/2 multiplied by our t, which is equal to x all over our VO cosine theta squared. Okay? So, for further manipulation of this equation, i-apply natin yung natin, trigo functions natin. Take note that sine theta all over cosine theta is always equal to our tan theta. Diba? So, we have y therefore is equal to tan theta x. Right? Tan theta kasi magka-cancel out to. Magka-cancel out yan. Tama ba? Then we will have negative g multiplied by 1 half multiplied by x over VO cosine theta squared. Okay? So this will be our formula of trajectory. So, take note, that halos nang ginawa ko is substitute lang. Actually, you can solve any problem by only using these two component ng vertical and horizontal translation nyo. So, pag alam nyo lang i-convert lahat ng vectors nyo into your x and y component, therefore, it would be very easy. And then next, after converting it, go back to the basic by getting its resultant. Your VR, your AR, and your R or your DR or your SR. Okay? Yung X and Y trajectory nyo. Okay? So, yan. That would be our first session for our review. So, let us use these formulas by setting an example.